Okay, so on block day, we talked about deductive versus inductive reasoning. We had 4 boxes, okay? Wanted to remind you of the shorthand writing for P and Q. I gave an example of if the sun is out, then the weather is good. So if the sun is out is like the P and the weather is out is like the Q. So if P then Q is our conditional statement. So our conditional statement right here. If P then Q makes a lot of sense. So we found the converse was if Q then P. Just switch the hypothesis and the conclusion. The inverse was if not P, then not Q. And the contrapositive is if not Q, then not P. And remembering that the contrapositive and the original statement are equal valid arguments. Okay, then we went on and we talked about the laws of logic. And we talked about the similarities and differences between deductive reasoning versus inductive reasoning, okay? So deductive reasoning uses facts, okay? It uses facts versus inductive reasoning using previous examples. Deductive reasoning uses definitions, theorems, postulates, axiom, where inductive reasoning uses patterns. All right? Deductive reasoning, it uses accepted properties. Inductive reasonings, they make a conjecture. Of course, conjecture is the fancy word for hypothesis or like a guess. Okay? So we had some examples. I said... Okay, last week the cafeterias, Maria notices that every Wednesday the cafeteria serves mac and cheese. Today is Wednesday, so she thinks that today they're going to have mac and cheese. That'd be an example of inductive reasoning because she's basing her conclusion off of previous patterns and previous examples, right? Then we have one with a driver's license in Nevada, and that was deductive reasoning. That's in the book if you want to check it out. Then we talked about truth tables here. Okay, truth tables are super fun and rad. We had the hypothesis, the conclusion. So we set up the hypothesis for P and the conclusion for Q. So we said, okay, the hypothesis can be true or false or true and false, given the fact that we have 2 of these things, and then the conclusion can be true, false, false, true. This is every kind of possible combination you can have between a truth and a false. So the first one was pretty straightforward. So if your hypothesis is true, your conclusion is true, well then P implies Q is definitely a true statement. Then we said, okay, if your hypothesis is true but your conclusion is false, well that's pretty obvious. It's a false statement, right? Because you start with something true, you end on something false. The whole thing is false. But these two, put little stars next to them. Okay, these two gave everybody kind of a run for their money. And it's kind of hard to understand, but we came up with, okay, if the first thing's false and the second thing is false, then the whole statement is true. And I gave an example, said, okay, if the sky is purple, like deep purple, okay, then we are all leprechauns, okay? So the only way that you would prove that this is not true is by finding a counterexample, all right? And so can anyone think of a day when we were not a leprechaun, but the sky was still purple? Well, no, we can't. So since we can't find a counterexample, if false, then false implies a true statement. So this was kind of strange. So generally speaking, if your hypothesis is false, your conclusion, P implies Q, will be true. So kind of an interesting statement there. We also talked about the law of detachment and then the law of syllogism. I can't really pronounce that word very well. Anyways, we said, okay, we have Bob, Sam, and Sheila. Bob is the shortest, Sam's in the middle, Sheila's the tallest. So if Bob is shorter than Sam and Sam is shorter than Sheila, then Bob is shorter than Sheila. That's the law of syllogism right there. I just don't know how you say that. Okay, then, that was it. All right, so make sure you check that out and go over this if you need to. Download the notes. Nice job, geometry.